For today, we're going to look at the exponential function. Exponential because that's where my variable x is. We've seen quadratics, which is x to the second power. Cubics, x to the third power. Now we're taking the x, and it's going to be the power. So 2 to the x power.
Wait, how does that even work?
Well, you just put it as power. If I were to look at the graph, it would look something like this, and we'll talk more about the graph in a second. If I look at the table, I notice...
What?
Well, any number to the 0 power is what?
0 power?
No,
1.
it's 1. Always going to be 1.
So cast for truth.
Now look at my xy's. 1 is 2, 2 is 4, 3 is 8. So I see it is increasing, and it's increasing kind of slow. But then look what happens. 16, 64, 512, 1,000. So I went from 1 to 1,000 in just 10 units, and I went from 1,000 to,
What the? That's a
million in 10 units.
Go back up.
So it took you 10 units to get to 1,000, and then the next 10 units, you already jumped to 1,000,000. That's how quickly this rises.
Wait, go back up.
Go back up
To 7.
to 7.
Okay. Never mind.
So, as we saw here, 0 is 1. Anything raised to the 0 power is the number 1.
Okay.
What if I put negatives? What happens to my numbers?
They decrease.
Well, not just decreasing, but they're getting smaller and smaller and smaller, right? Will I ever get to a 0?
No.
No, you will never get to a 0. So as my graph comes here and gets close to 0,
But
it's going to get
It's
smaller.
hovering it.
Yeah, it's going to get smaller and smaller and smaller, closer and closer to 0, but it won't get there. That's, if you can remember from rational functions, an asymptote. So we will have a horizontal asymptote with exponential functions. Let me show you some demonstrations. So let's see. Here's one of my favorite, the Titanic. Somebody made a video of the live play-by-play by the second of what happened with the sinking of the Titanic. So it actually took 2 hours and 40 minutes to sink.
I just fast forward before now.
So notice how it hit the iceberg 8 minutes ago. Ship's still looking okay, right?
It hit the iceberg was under the water.
Bro, gallons
Yeah.
and gallons of water are going inside of that boat right now.
They are. Look, it hit the iceberg an hour ago. Still, most of it's above water, is it
I
not?
guarantee
I don't get how so many people died from that though.
That's what I'm saying.
Well, this is an hour later. Well, they were probably in denial, like COVID. Oh, COVID isn't real. Oh, no, we're not really sinking. No, this is a joke.
Yeah, the boat's like halfway up in the air.
Look, it also goes by all the witnesses. So the deck gate doors are open to assist in loading of the boats. They are never used.
For real, the boat's like this in the water and I'm like, damn.
So let's go 2 hours later. Oh, so the main below Donahall's underwater. Let's look at the ship here. 2 hours later, I got part of my boat underwater now.
That part of my boat's in the
I'm
water.
pissed. They know what's up one of those sheets.
The hull's underwater. So it took 2 hours to get to this point.
We're not sinking, it's turbulence.
Let's go here. So 1 hour and 30 minutes.
I'm just tired, boy. No. In the
2
bed,
hours.
underwater drowning.
Let's see.
Imagine being asleep, bro. The lady sort of.
So now the bridge is underwater. It took
Feel water.
it took 2 hours and 30 minutes to get there.
You wake up underwater, you fall.
According to this video, the ship is going to sink in 8 minutes. Notice how much of the boat is still up. All right.
You got 8 minutes to live. What would you do?
And let's see here. Oh,
Punch you.
looks like half the boat is now underwater. So it took 2 hours and 37 minutes for half the boat to get underwater. And then it's going to take just another 4 minutes for the rest of it just to sink.
Damn, in the movie it summed it up in like 5 minutes.
The logic that we have.
All right. Here is another example. So if you go to today's page, I got a couple of links here that's going to help you. Zombie game.
Zombie game.
Let's look at this zombie game created by Texas Tech.
Texas Tech.
Yeah, they spent $1 million on a server to come up with zombie demonstrations. I'm going to have my zombies twice as fast as humans because they're hungry. Should I give my humans guns?
Yes.
Let's give them weapons.
No. Hell yeah. Is that marshmallow shotgun?
Yeah. All right. So here we go. The red indicates my human population and the green is my zombie. I'm going to start. There's 200 humans and 1 zombie. Let's see how long it takes to infect one person.
Wait,
He's getting shot, so he's being stunned.
Oh, stop playing with that boy. Gone.
Dude, everybody's avoiding him.
Everybody's avoiding him, yep.
Oh,
Oh.
you got one.
It took 18 seconds for the first human. Let's see how long it takes for the rest of the population.
Damn.
Then you saw that? They cornered that one guy. He almost got
Man,
out.
if they ain't gonna corner me, I'm gonna be running for my life.
Here's a perfect example of exponential growth.
Off screen.
Oh.
It's a wall. It's not fair, Mr. Clark. It's not fair.
Where you
It
gonna-
took 39 seconds for half the population to be infected,
Damn.
and then another
Is the
time,
last one survive?
46. So 7 seconds for the rest of the half. Just like the Titanic.
That ain't fair. That ain't fair.
So here's a link. You can play with this just to see exponential growth live.
That's cool.
So it takes a long time for him to affect one. A little bit less time for him to affect those one to become two, those two become four, and
So
spread.
it's
So it's
different,
like-
it's different scenarios every time, right?
It's like cellular diffusion.
Well, it's kind of like exactly how viruses work. You got one virus cell in your body and it kills a red blood cell. This is how you get sick. This is how you get COVID right here. This is what's going on in your body.
COVID is in my body.
That's how,
Look,
it's
and then it just gets out of hand, and then you're pretty much.
Eat and breathe.
got the flu.
That just pretty much
Breathe
sums
in
up
my
the
voice.
United States.
So that took even faster than last time. So exponential growth. Also, speaking of COVID,
I got COVID.
here's a link.
To how to get COVID for free.
No. So this demonstrates the first 50 days after the first human was infected with COVID in the United States.
Fucking Mr.
Here's the first 50 days.
That boy say he needs to breathe.
Notice how this green line is a regression on that exponential, and the black is an actual exponential line that kind of models it. Look how it starts off almost exactly like an exponential model. So that's what we were trying to avoid, because this blue line represents the shutdown. This is when we had our stay-at-home order right after spring break. Notice how it took 50 days for 45,000 Americans to get infected. How many days do you think it'll take for all of Texas?
Damn.
If it continued with this black model.
Like a date.
Well, not days,
No.
we're talking about 25 million. To go from 45,000 to 25 million, how many days?
Probably about like 2 years.
3 weeks for all of
3
us.
weeks? 2 years? Let's see.
2 years.
What the?
Almost there. So here we go. It would take 88 days. From patient 0, 88 days, everybody in Texas has COVID. If it continued with that model. Yeah, scratch that, because watch, you'll see. Let me lower this. All right. So here is my basic parent function. I have some number 2 to the x power. If I have a number on the outside, what happens to my graph?
It increases, it goes up now.
Goes up and down, right?
That's the X.
Now notice I mentioned that I do have an asymptote here.
Y equals D.
Y equals D, yep. Y equals my shift. If there's no shift, then Y equals 0.
Ah.
Because notice how my graph is going to get close to 0, but it's not going to equal it. As I shift my graph up, does my asymptote follow it? Yes. So if I go up 2, notice now I no longer have any values that are 2 or less with my exponent. If I were to go down, the horizontal asymptote also follows my graph. So if I go down to -4, then I will have values less than 0, but never equal to or less than -4. So if you want to quickly see what is my horizontal asymptote, well, just look at the D. What is being added or subtracted on the outside? Let's see here. Come on, pulling up. There we go. So if I have 2x plus 3, what's my asymptote going to be? Y equals 3. If I have 2x minus 6, what's my asymptote? Y equals -6. Yeah. Asymptotes are really easy to see with exponentials. You're just looking at that up and down shift. Because as you see with these other changes, they don't affect that horizontal. It'll always be 0 if it sits at 0. So now let's go to C, which means looks like I'm being added or subtracted a value here with x. So all values that are going to be attached with my exponent. So let's go go here. Oops. Go over there. So like x minus 3. Which way do my graph shift with that negative 3 here with the x, with the exponent? Well, let's look. X minus 3, and it shifted to the right 3. So notice those numbers, add and subtracting with your exponent, shifts it left and right. Let's see here, let's put that back to 0. Now, like I said, our exponent is the x. So we have some base number we raise to the exponent, we'll call it n here. As I increase that value, it just kind of sharpens my curve a little bit. But notice as these values get larger, let's go to 100, it really doesn't make that much change. Notice how it's not changing too much now. That's because you're just basically raising a high power to an already higher power. It's already going to be a large number, so you're not going to see that much of a change once you get to these large numbers. If you have small numbers like a decimal, notice how it kind of flattens my curve out, which is important for today's activity. Making that a small decimal number.
I'm important for today.
And let's put that back to, let's say, 2. Let me zoom in back here. Oops, wrong one. That needs to go to 2. We'll stick with 3. We'll make that back to 1. All right. Now, one more thing. Stretch and compress. This is a little misleading, so make sure you pay attention. A's my number out here being multiplied to all of this. If I'm increasing, it kind of looks like it's shifting left, right? But that's not what's going on.
It's shifting up.
It's shifting right.
Well, picture I'm taking this top here, and I'm pulling up.
Yeah,
What happens when I pull it up?
It's going up. It's getting higher. It's
Well, it's stretching.
Oh, increasing.
Notice how this curve here is not really moving too much. I'm stretching it from that pivot point.
Oh.
So it's like
How did we not notice that? What was that?
dude,
So
I
the
noticed
stretch.
that. I just didn't know how to
As I
explain
get
it.
lower, I'm pushing on the top. It's flattening it out.
Yeah.
Pushing, pushing. It's not moving to the right. It's getting flatter.
It's stretching. It's compressing
It's
everything.
compressing. And if it happens to be a negative, then it reflects across the x.
Nigga chin.
So here's the way to play with your graph there.